All right, test 2, section 4, number 35. This one is giving you an equation, and before you read this big paragraph, what you want to kind of look at is notice that this is nothing more than a slope-intercept form equation. So we got a rate, which is 18, and we have our y-intercept, our initial value of 15. So you see this equation, it's linear, so we're going to use those same properties as we always do. Now, kind of scrolling through this problem, they're spending most of the time explaining to you what the A and the T mean. What I want to do is kind of get down to the actual question, which is one of the last sentences. It says, according to the model, how many dollars was Jane's, and the key word here is the word initial deposit. So anytime they say something that means starting point, initial, they use that word, we're asking for the y-intercept. All they're doing here is saying, what's the y-intercept of this equation? So your answer is going to be 15 because that's your initial value. So that's what you're going to have for number 35. That is it. There's really nothing else to it than that. So again, you see this format here, linear equation, slope-intercept form. Make sure you're aware of that. So again, that's 35. Next up is 36. And on this one, they're giving you a picture. You obviously want to try to draw some things. There are some things that you can probably assume, but always try to confirm it with the question itself. But usually they're not tricking you with pictures. If something looks like it's at a certain angle, it probably is. But let's go ahead and do this anyway. So in this problem, it says in the figure above, point O is the center of the circle, which we can tell. And then line segments LM and MN, so LM and MN, are tangent to the circle at points L and N. So what we have to know is when they say the word tangent, what does that mean? Well, we have this radius here and we have a tangent line. So the geometry concept you need to be aware of is tangent lines are perpendicular to the radius. So they just gave you these two angles without telling you what those angles are. So those angles are 90 degrees. And from here, I can find angle O, because if you look, we basically have a kite. There's the four sides. You can call it a kite. I mean, it is. It's just quadrilateral is really what you really need to know in the end. But anyway, I'll get to that in just a second. They're saying if the circumference is 96, what is the length of minor arc LN? So the circumference, I'll write this down, but I'm going to come back to it here in a second. But again, the circumference they said is 96. So what you need to do when they give you a circumference or an area or a perimeter or whatever it is, set it equal to the equation. So when I say circumference, I'm going to say 2 pi r is equal to 96 because that tells me what I need to find. I need to find the radius. That's going to be important to solve this problem. And in order to find this minor arc LN, what I need to do, and again, if I'm doing the length of a sector, so what you're doing is you're going to take the angle divided by 360, and I want to find a length of a sector. I'm going to multiply that by the circumference, which is 2 pi r. So actually, in this case, it looks like I don't actually need the radius because I have this. So I really just need to find that angle, which I can find relatively quickly, and then I can find that length. So I wrote down my formulas. It helps me figure out what I need to find. They gave me the circumference, which I said is 2 pi r. This still helped me because to find the length of a sector, it's a portion of the circumference. So to find the portion of the circumference, you multiply the actual total circumference by the angle divided by 360. So when I kind of look at all this, I'm actually just going to be doing this math, x over 360 times 96. I need to find that angle. So let's come back to the picture. Let's find that angle. As I said earlier, this is this four-sided figure, this quadrilateral. These four angles are going to add up. By the way, that's x. Those four angles are going to add up to 360. So I know that x plus 90 plus 90, so 180, plus 60, those angles are going to add up to 360 degrees. So that means x plus 240 is equal to 360. And if you subtract 240 from both sides, we're going to get 120 degrees for x. So I have my angle, which means I can come over here. I can find the length of that sector. I'm now going to take this. That's 120 over 360. that's actually going to equal 122, that's 2/3, or 1/3 actually, sorry. So that's 1, it's a 1/3 times 96. And we're just going to go 1/3 times 96, which if I do that, 1/3 times 96 is going to give me 32. So that's going to be the length of my sector, and that's all we need to say for number 36. 36 is 32. Now, lastly, we have 37 and 38. So on 37 and 38, they're both going to be using this formula that I have written up here. Now, they tell you what this all means, which is important. So we got a botanist is cultivating a rare species of plant in a controlled environment and currently has 3,000 of these plants. So that's what we have right now. So I would say, and that's probably, good to note. I'm going to put it, the current we're looking at is 3,000. So I'll add that information in there. The population of this species that the botanist expects to grow next year, which is N of next year, can be determined from this equation below. The constant K in this formula is the number of plants the environment is able to support. So, I'll just say K is able to support. And again, this is all stuff you don't always obviously have to write down, but these are the things that you need to know. So you need to know the equation, and I bet you that 3,000 is going to be really useful because there's a lot of stuff we don't have right now that we're going to need to plug in. So according to 37, it says, according to the formula, what will be the number of plants 2 years from now if K is 4,000? So we want to go 2 years into the future. Well, they're giving us K, so they're giving us this, and we've already been given the current value. So they want to say 2 years from now. Well, currently we have 3,000. So I'm going to use this equation. I'm going to actually have to do it twice. I'm going to plug it in for next year, and then I'm going to have to do it again to get the year after that. Again, that's going to be my 2 years. So the N of next year, I'm just going to call that N because N of this year is going to be 3,000. So that way I don't have to write next year every time. That would be annoying. So I'm just going to go N, that's next year, equals N of this year, which is 3,000, which they gave me, plus 0.2 times N of this year, which is 3,000. And that's getting multiplied by 1 minus, and then we have N of this year divided by K. Well, K, they said, was what, 4,000? So I have 3,000 over 4,000. So that is the equation we're plugging in. We're going to have to do this twice, but that'll at least give us the 1 year later. So this gets plugged into your calculator. Just be careful when you plug it in. So I'm just going to go 3,000 plus, and I'm going to do all this stuff off to the side. A little bit way to help you out here. 3,000 over 4,000 is 3/4 or 0.75. So this is 1 minus 0.75. So I'm going to write that on my calculator as just 0.25. It's going to make this a little easier to do the math on the calculator with. You can do however you want. Just make sure we get the numbers plugged in, right? I'm going to go 0.2 times 3,000 times 0.25. So this is going to be plus 150. So we end up with 3,150. So that is 1 year later how much we have. So be aware, I'm going to have to do this twice. So that's 1 year later. And we have to do this one more time. Now, this is our current amount. So our current amount has changed from 3,000 to 3,150. So to get to next year, I'm going to go N again. This is giving me to my second year, equals N of the current year, which is now 3,150, plus 0.2 times 3,150. And that is times, now this is 1 minus, now we'll need to focus in on our calculator a little bit more, but it's going to be 1 minus 3,150 divided by my constant, how much they're able to support, which is 4,000. So again, I'm doing this one more time, but I just changed that current year's value. So I'm going to take that 3,150 plus 0.2 times 3,150 times, and I'm going to go 1 minus, and this is 3,150 divided by 4,000. If you do it correctly on your calculator, you're going to get 3283.8 0.875. So this one they said round your answer to the nearest whole number, so it's okay if you don't get a whole number because it doesn't sound like you're supposed to. So you just round it to the nearest whole number, which is 3,284. That's what you'll plug in for number 37. So that's 37. Finally, we have number 38. And let's see, I haven't used green. Here we go. 38, we have the botanist would like to increase the number of plants that the environment can support. So they want to increase K. So they want to increase that so that the population of the species will increase more rapidly. So if the botanist's goal is that the number of plants will increase from 3,000 this year, so N of this year is going to be 3,000, and we want to get 3,360 next year. So they're giving us these two numbers. They want us to find out how many plants the environment must be able to support, so they want us to solve for K. So we're plugging in for these numbers here, and we're solving for K. So we just set this up, and we have to do a little bit of algebra here, but we'll make it work. So end of next year, they said, is 3,360. So I'm going to go 3,360 equals end of this year, which they said is 3,000, plus 0.2 times 3,000. I'm running out of room here, so I'm going to go ahead and move this down. This is times again, but it's 1 minus end of this year, which is 3,000 over K. So I'm going to work with this equation a little bit. First thing I'm going to do, let's subtract 3,000 on both sides. I'm going to move it to the other side. That'll make this a little nicer looking. I should be able to fit it on the board here. So this will be 360 equals, and I'm going to also multiply these two numbers together just to make this a little simpler looking. So 0.2 times 3,000 is 600 times 1 minus 3,000 divided by K. Okay, so that cleaned things up a lot. And again, all I did is subtracted 3,000 from both sides, and I multiplied those two numbers together. Now, next I'm going to divide both sides by 600. Again, there's a lot of different ways you can approach this right now, but that's just, I figured let's just get that out of there. So 360 divided by 600 is 0.6. So now I have 0.6 equals 1 minus 3,000 over K. So I'm getting there. So next up, what should I do? I'll probably just subtract 1 from both sides. It makes it a little bit nicer looking, so I can now work as this out as a proportion for my final step. So I'm subtracting 1 from both sides. So it's going to give me negative 0.4 equals negative 3,000 over K. Next thing I would probably do, and again, you can do this in one step, but I'm going to show all the steps. I'm going to cancel out that negative. Technically, you're dividing both sides by negative 1, but they're both a negative. I can cancel them out. So I now have 0.4. I'm going to put that over 1 equals 3,000 over K. If you don't realize why I put it over 1, it's because this is a proportion now. And the reason why I'm solving it as a proportion, I have a variable in the denominator. So I'm going to make this over 1, and I'm going to do cross product property. So that's 0.4 times K equals 1 times 3,000. And then we're just going to divide both sides by 0.4. And that's going to give me K equals 7,500. So that is the answer you're going to plug in for number 38. And that is test 2, section 4.